Hello viewers, welcome to the another interesting subject of electronics and communication engineering. In these segments, we are going to discuss digital signal processing or DSP. These video lectures are totally conducted by Ganon, powered by Wishback. I am Professor Aditya De. I will be your mentor throughout this course. Now let us start DSP or digital signal processing introduction. Now in the diagram shows how a digital signal processing is used in an MP3 media player. You are already familiar with MP3 media player, isn't it? You are using MP3 media player in your daily life, almost every day, almost every moment, right? So what happened in the MP3 media player? During the recording phase, analog audio is input through the receiver or other source. This analog signal is then converted to digital signal by an analog to digital converter and passed to a DSP kit or digital signal processing kit. The DSP performs the MP3 encoding and saves the file to the memory. During the playback phase, the file is taken from memory, decoded by the DSP and then converted back to an analog signal through the digital to analog converter. So it can be output through the speaker system. In a more complex example, the DSP would perform other functions such as volume control, equalization, and user interface. Interesting, isn't it? Okay, let's go. A DSP information can be used by a computer to control such things as security, telephone, home theater system, and video compression. You are listening lecture through the computer or through your smartphone, isn't it? So there is also one digital signal processing kit. A computer takes input through the keyboard, process it, and display. Speaker sound can be processed by this DSP. Signal may be compressed so that they can be transmitted quickly and more efficiently from one place to another. For example, teleconferencing can transmit speech and video signals via telephone lines. Signal may also be enhanced or manipulated to improve their quality or provide information that is not sensed by humans. For example, echo cancellation for cell phones or computer-enhanced medical images. Whenever you are talking with your friends, sometimes you will hear your own voice. That is an echo. If there is no echo cancellation or bad DSP, worse DSP, then you can hear your own voice. That is a problem. Okay. Although real-world signals can be processed in their analog form, processing signal digitally provide the advantages of high speed and accuracy. Now, what is there inside a DSP? A DSP contains this key component. One is program memory, which stores the program the DSP will use to process data. There is one data memory, which stores the information to be processed. There is one compute engine, perform the math processing, accessing the program from program memory and the data from the data memory. And obviously there is some input or output which serves a range of functions to connect to the outside world. Now let us discuss the ADC and DAC. Electric equipment is heavily used in nearly every field. Analog to digital converters or ADC and digital to analog converter DAC are essential components for any variation of DSP in any field. These two converting interfaces are necessary to convert real-world signals to allow for digital electronic equipment to pick up any analog signal and then process it. Take one microphone, for example. The ADC converts the analog signal collected by an input to audio equipment into digital signal that can be outputted by speaker or monitors. While it is passing through the audio equipment to the computer, software can add echoes or adjust the tempo and pitch of the voice to get a perfect sound. On the other hand, DAC will convert the already processed digital signal back into the analog signal that is used by audio output equipment such as speakers. The analog signal is as shown in the figure. The corresponding digital signal is as shown in the figure. The sampled signal is as shown. Now let us discuss ADC. A type of analog to digital converter known as digital ramp ADC involves a comparator. The value of the analog voltage at some point in time is compared with a given standard voltage. One way to achieve this is by applying the analog voltage to one terminal of the comparator and trigger known as binary counter, which drives a DAC, while the output of the DAC is implemented to the other terminal of the comparator. It will trigger a signal if the voltage exceeds the analog voltage input. The transition of the comparator stops the binary counter, which then holds the digital value corresponding to the analog voltage at that point. Now let us discuss digital signal processing applications. It is used in speech processing or speech technology or sound reproducing. It may be used in image processing. It can also be used in medical or biometric image processing. It is also used in sonar or radar. It is used in mobile communication, telecommunication industry. It is used in voice over IP or VoIP, voice lock, automated voice, and it is also used in seismology. Now let us discuss the advantage of the digital signal processing. DSP has a high level of accuracy. The filtered design DSP have firm control over output accuracy as compared to analog filter. The reconfiguration in an analog system is very high, tough, because the entire hardware and its component will have to be changed. On the contrary, a DSP reconfiguration is much more comfortable as only the code or the DSP program needs to be flashed after making the changes according to the requirements. The interface types offered by DSP are like UART, I2C, and the others. This helps in interfacing other ICs with the DSP. The combination of DSP interface with FPGA helps in designing the protocol stack of the whole wireless system like WiMAX, LTE, etc. In this type of architecture, as per the latency requirement, few of the modules are ported on FPGA and the other few on DSP. Implementation in digital is much more cost effective than its analog counterpart. The digital system in DSP can easily cascaded without any problem in loading. Digital circuits can be easily reproduced in huge quantities cost effectively. Accessible transportation is possible because digital signal can be processed offline. Using the DSP method, sophisticated signal processing algorithm can be implemented. Now obviously everything has some disadvantage. Now let us discuss disadvantage of DSP. When using DSP, there is a need for using anti-aliasing filter before ADC, analog to digital converter, as well as using reconstruction filter after DAC, digital to analog converter. Due to this use of extra two module with ADC and DAC, the complexity of DSP based hardware increases. Number two disadvantage is digital signal processes the signal at high speed and comprises of more top interval hardware resources. Because of this, DSP dissipates higher power as compared to the analog signal processing. Analog signal processing includes passive components that consume lower energy. Number three disadvantage is each DSP has different hardware architecture and software instructions. Due to this, only highly skilled engineers can program the device. Proper training on the DSP required for programming for various applications. Number four disadvantage is one need to cautiously use the IC as per the hardware and software requirement, as most of the DSP chip is very expensive. Number 5 disadvantage is only in synchronous communication system the detection of digital signal is possible, but it not so in case of analog system. Higher bandwidth is required for digital communication than analog for transmission of the same information. So what we have discussed today? We have discussed today digital signal processing introduction, internal structure of DSP, then we discussed application of the DSP as well as advantage and the disadvantage of the DSP. That's all for this segment. So welcome to the world of digital signal processing. Thank you viewers. Bye.